Hello, it's Helen. Today I will talk about building some machine learning pipelines using PKRS and scikit-learn. The dataset I use is about Alzheimer disease. So I use the data OS 2 from their website. The data have 150 people and they all have at least one and up to five visits. Each time they have the MRI section, and we have in total 373 records for all of them. So there's some of them in the group of demented, the other in the group of non-demented, and some of them converted. It means at first they are non-demented, and after that they change the status to demented. I also have the column description with on the full name of the column and the link. So if we need to deep dive into that, we can just click the link. So for EDAs, I will use pandas, seaborns, and wide data profiling. So here the data set is an Excel file. I look at the shape of the data set. I use the bright to look at the min marks and the distribution of the data. And we do have some no value. Yeah, we will do that later. And we I also use wide data profiling to have this overview of the data. We can have a better look here too. So there are a lot of information here. I just summary some of them inside the notebook with Seaborn. So here the group distribution, we have more non-demented and very little converted group, and we will manage that later on. So for the gender, it's slightly more people male with dementia than female for the data set. And we also looked at the correlation on the field. So by the look of that, we can see some very strong correlation between the brain volume and the ASF. So it's Atlas factor. So I will consider crop one of two field for the model. And you can see that the CDA, the clinical dementia rating, have very strong correlation with the mini mental state examination. And also the social economic status have very strong correlation with the education level. So those things we will keep in mind and use that for the imputation. And I also do some pair plots to see some collinearity between the fields. And also there are some difference between the groups in some field. So CDR is the most significant one. I plotted here. And also the normalized wide brain volume, also a little bit different here. So after the EDA, I can see that there's some important finding here. So the age of the group is between 60 to 98, medium is 77, and the education, most of them had education of 12 years, but the maximum is 23, and it have a high correlation. So for the no value in SES, I will use this correlation to replace by the mean of the people have the same education level and the same with CDR. So I will use that to fill the known value for MMSE. Yep. So after that, we go to the data cleansing. Yeah, so I replay on the value from the SCS by the median of all the people in the same group of education. The same thing with MMSE. And after that, I check the data again to make sure that there are uh, no value here. And the column M and F, the gender one, are now before we have F for female and M for male. So I put it 0 and 1 so that we have all number. And we have a look at the value count here. So for the first visit, we have 14 the people under converted group. We know for sure that those people for the first visit, they still non-demented. So later I will move all of them to the non-demented group, not to confuse the model, because at that point they still non-demented. And we have 64 demented, 72, 64 demented and 72 non-demented. And yeah, that's our plan for model. So now the group of people who's in the group of converted and the visits is not the first one, I will delete it from my data set. And after that, I have the data set of 350. The data set I will change on the people in the group of converted to non-demented. After on, I will have more than 200 in non-demented and 146 for demented. And I will drop on the column that's irrelevant to the prediction, like the subject ID, MID, and the hand. I also drop that because all the people in the dataset are right-handed, so it doesn't contribute anything for my model. And the ASF also because the high correlation with the ETIV, so I keep only one field. After that, I save all of them. This data to use for the next step of building the model.